All right. Today's lesson will be in our textbook. It's on section 133. So if we think back to what we did last week, we were working on adding and subtracting different complex numbers. Today we're going to work on the skill of multiplying complex numbers. We're also going to go over what the complex conjugate is, which is a new vocab word in relation to complex numbers. And we'll talk about what we can do with that with finding products of complex numbers. So if you don't have it out already, let's get out our textbook. We're going to open up to page 75 where this lesson starts. We're going to use this page on 75 to work through some a little bit simpler multiplying problems with complex numbers. So kind of our building block skills that we'll use in future parts later on. Okay, so for example, example 1 says find the result or the product when we do I times 5i. I'm going to rewrite it to start. I times 5i. We think back to last week and also thinking about the warm-up we just completed. A reminder that even though I is not a variable and it represents the square root of -1, in terms of our properties that we can use when we're combining or multiplying complex numbers, we can think of that I a lot like how we would a variable. It's not a variable, right? But in terms of our rules, we can think of it that way, okay? So if we were doing I times 5i, it acts a lot like how it would be if it was x times 5x. Right, x times 5x, there's really a 1 in front of the x, so we'd multiply the 1 and the 5, make 5. We multiply the x and the x, make an x squared. Okay, so keeping that in the back of our head. Okay, here, I times 5i, it's very similar, right? There's really a 1 in front of this I. So 1 times 5, we get 5. I times I, that's I squared. Now we can go further than that though, right? Because we have to remember in the back of our heads that if I is the square root of -1, then I squared, well, that would just be -1. So we can take this one step further because this is just an I squared at the end. Well, that's just 5 times -1. 5 times -1, our answer is just -5. Okay, so I times 5i simplified down to just -5. So we're going to start by doing some more practice problems that are similar to this. You can stay on this page. Let's try these couple ones. Okay, so we have number 1 here. Okay, so it says 2i times the parentheses 3 minus 7i. So now we're distributing, right? We're distributing this 2i, both terms that come after. Well, 2i times 3, that would be 6i. Then 2i times -7i, well, 2 times -7 minus 14. I times I squared. We're not done though. Okay, we have a power of I in there. We're never going to leave our result if it just has a power of I in there, because we know from last week that we can always simplify that. Well, here we have I squared. Again, in the back of our heads, we remember that I squared is just -1. We can simplify this further. 6i minus 14 times, instead of I squared, -1. Well, let's keep simplifying. So we still have 6i, and -14 times -1, that'd be plus 14. We wouldn't leave our answer like this because this isn't how we've seen complex numbers written. Remember, complex numbers are typically written in the form a plus b times I, where a is the real component, sorry about that, and b times I is the imaginary component. So let's rewrite this in the other order, bringing the 14 to the front. 14 plus 6i. That would be our answer. Okay. Let's try another one. Okay, so we look at 2. Now we're double distributing. Okay, so we're going to, thinking back to what we did earlier in the year with double distributing, we're going to multiply this 3 to both. So we do 3 times 8, 24. 3 times 2i plus 6i. Then we would multiply the 4i to both. 4i times 8 plus 32i. 4i times 2i, well, that'd be plus 8i squared. Again, we're not done because there's a lot of simplifying we can do. Personally, I'm going to start by changing that I squared that's at the end to our -1, since that's that key idea that we remember. So we have 24 plus 6i plus 32i, and we have plus 8 times -1. Now we know 8 times -1, that's just -8. So we have 24 plus 6i plus 32i minus 8. And then there's some like terms that we can combine. So we can combine the 24 and the minus 8. So 24 minus 8, 16. And then we can combine the 6i and the 32i, make plus 38i. So 16 plus 38i, that's fully simplified. That's a complex number. That's our answer. Okay. So let's keep practicing skills with multiplying complex numbers. Okay, so now we're on page 76. Let's try one more like that where we're double distributing. Okay, so we're going to multiply the 7, both terms in the back. So 7 times 4, 28. 7 times 3i plus 21i. Then we're going to multiply the 2i to both terms in the back. 2i times 4 plus 8i. 2i times 3i plus 6i squared. And we can't have powers of I in there. Okay, so we're going to rewrite that I squared as -1. 28 plus 21i plus 8i plus 6 times -1. Well, 6 times -1, that's just -6. And then it's just a combining like terms problem to make this as simple as possible. Let's combine the 28 and the -6, 22. And then let's combine the plus 21i and the plus 8i, make plus 29i. 22 plus 29i. And we're going to leave it like this with the real number in front, the imaginary number in the back. Complex numbers, always the real components written first, then the imaginary component. Let's get some more practice with this. Okay, so now just find a blank page in the book. You have tons of them. Why don't you guys start by doing number 1 and then number 2. We'll check in and see how we did. Okay, so number 1, this is a distributing problem. Multiply the 8i to both of those terms. 8i times 6, that's 48i. 8i times -9i, that'd be minus 72i squared. Remember that I squared is -1. Really, we have 48i minus 72 times -1. -72 times -1, that's positive 72. I'm also going to bring that to the front. So we have 72 plus 48i. That would be our final answer. Try 2. So -3i, multiply that to both. -3i times 2, that's -6i. -3i times -8i would be plus 24i squared. Rewrite that I squared as -1. 24 times -1, that's -24 minus 6i. And we can't combine those, right? Because this one's a real number, this is an imaginary number. There's nothing else we can do there. That would be our answer. Okay. All right. Why don't you guys try to do 3 and 4? Okay. Number 3, you got to double distribute. We're going to multiply the 2 to both. So 2 times 7, 14. 2 times 4i plus 8i. 3i gets multiplied to both. 3i times 7 plus 21i. 3i times 4i plus 12i squared. Okay, now we got a bunch of simplifying to do. So I'm going to rewrite the I squared. Okay, so we have 14 plus 8i plus 21i plus 12 times negative 1. You know 12 times negative 1 is minus 12. And then it's just combining like terms at the end. So I could combine the 14 and the minus 12 to make 2. And I could combine the 8i, I could combine the 8i and the 21i to make 29i. Final answer, 2 plus 29i. Okay, one more. Look at 4. So I'm going to start by multiplying the 9 to both. 9 times 5, 45. 9 times 7i plus 63i. Multiply the negative 10i to both. So negative 10i times 5 minus 50i. Negative 10i times 7i minus 70i squared. Sorry, ran out of room there in the corner. Okay, so then we'd have 45 plus 63i minus 50i minus 70 times negative 1. Rewrite that piece at the back. So negative 70i, or negative 70 times negative 1, that'd be plus 70. Finally, we combine our like terms. So combine the 45 and the 70. That make 115. Combine 63i minus 50i to make plus 13i. So we have 115 plus 13. And you want to write it in this order because that's a complex number. Okay, so first skill for today, we're multiplying together complex numbers. Our other piece for today is discussing what's called the complex conjugates. We're going to go to page 76. Page 76. We have a definition to write down at the top. Okay, so the complex conjugate. The complex conjugate is the complex number you can multiply another complex number by that will always result in a real number. Okay, not a complex number, a real number. So complex numbers are always written in the form a plus b times I. So in this case, for example 3, we're going to do this problem here where it says find the complex conjugate of 5 minus I and then use multiplication to verify your answer. Let's first discuss what the conjugate is. Okay, so I wrote out some examples here and we're just going to practice writing out what the complex conjugate would be. So for example, we had 2 plus 4i. The way that we write out the complex conjugate is going to be flipping the sign in the middle. The conjugate of 2 plus 4i would be 2 minus 4i. Or negative 3 plus 5i would be negative 3 minus 5i. It's always flipping that middle sign. So 1 minus I would be 1 plus I. And negative 7 minus 2i, that'd be negative 7 plus 2i. Okay, that's our rule. The conjugate is when you flip the sign in front of the complex piece of the problem. Okay, so that's why it's important to always write your complex numbers as a plus bi. If the order is flipped, then you're going to flip the wrong sign. So now to complete our problem, it says find the complex conjugate of 5 minus I. Well, the complex conjugate would be flipping that sign in the middle, which is 5 plus I. So let's use multiplication to verify our answer. If we had 5 minus I, we're going to multiply that by the complex conjugate, in this case 5 plus I. And now let's see what happens when we do this. Okay, so we're going to multiply 5 to both. 5 times 5, 25. 5 times I plus 5i. And we're going to multiply the negative I to both. Negative I times 5, that'd be minus 5i. Then negative I times positive I minus I squared. Let's simplify. So hopefully we're seeing in the middle, plus 5i minus 5i. Those would cancel each other out. We also have an I squared here. So let's rewrite that I squared as negative 1. We have 25 minus, there's a minus in front, then I squared, that's negative 1. 25 minus negative 1, that'd be the same thing as 25 plus 1. We get 26. Okay. So a little note to put in our book, multiplying a complex number by its conjugate will produce a result that is wholly real. Okay, that's what it is. It's the complex number you can multiply another complex number by, where your result will be just a real number. Okay, so that's the complex conjugate. Okay, so again, our targets for today, multiplying together complex numbers, and identifying complex conjugate, verifying using multiplication. So multiplying a complex number by its conjugate, and getting that real number as the result. Okay, so that's our lesson for today.